Actually, I'm amazed that people turned up for this talk. When I was actually submitted this talk and they actually selected, I was like, I personally really enjoy doing talks like this, but I was thinking about like PHP developers and doing stuff with RPM. If I told somebody like that 2 years ago, I probably got either punched in the face or get laughed away or something like that, because we don't do that. We're PHP developers. We only do PHP work. We don't mess around with ops stuff or DevOps stuff, of system administration stuff. But I was thinking more about it, and all the worlds, the dev worlds and the op worlds, it's kind of faded away. It's just one big area and where everybody has one goal, namely try to make software and get people to actually use that software. So this talk is not really about, oh, you should do everything with RPM from now on. Well, you could, but I wouldn't really reckon that. But this is more like, this is another tool inside your toolbox. Yeah? If you have any reasons to use it, at least you know how to use it, you know what it is, but don't use it for everything. Like deploying your apps, use things like Capistrano, Capiforni, Webistrano, stuff like that. Don't create RPMs just for the sake of creating RPMs. Do that in your spare time, obviously, but not like really deploy your software. So, my name is Thijssen. I'm a freelance consultant and trainer. I do a lot of stuff in PHP, but also a lot of stuff in the operation world. So this is why I'm really interested in items like RPM and system administration. So before I start with packaging RPM packages, who actually knows about RPM? Who actually used it before? Okay, so that's quite a show of hands. Have you ever used it as like, I can install a package, or have you ever used it like, I'm creating my own packages? Created your own packages? Awesome, that's really nice. So for the people who have no idea what RPM is, RPM stands for Red Hat Package Manager. Now, this doesn't mean that it's only for Red Hat. It also means that it's also for all the derivatives, like CentOS and Fedora, etc. A lot of people will use Debian or Ubuntu. You could use RPMs on those systems as well, although I wouldn't really recommend it because it's quite a different infrastructure and it will make things a little bit more difficult. You can actually convert RPM packages to Debian packages with tools like Alien and everything, but I wouldn't really recommend it unless you really know what you're doing. So, why should we use package managers? And the best way to explain that to you is by a very, very simple graph. Anyone, any idea what this is? All right, Composer, right? Pretty much, Composer is really cool because now we have like bundles that we can just install and it sorts out all the dependencies we want, and we don't have to care about all the stuff we used to care about when trying to get something up and running, right? So now it's really simple. We just change something in a JSON, Composer JSON file, and all of a sudden everything will up and running, and it will take care of where it's going to find stuff, what for dependencies it needs, etc., etc. So, just like Composer, RPM, at least the RPM infrastructure, will take care of all the dependencies for you. It also means it takes less time to install, because if it will do that for me, makes it that I save time. Another thing is, and this is for things like installing PHP or other binaries, you don't need to compile it yourself. Has anyone tried to compile PHP from scratch? Okay, well that's fair enough amount of people. Obviously you can, and PHP is really not that difficult, but there are like tools out there that's really, really difficult to install. Version systems of your libraries are off, or all the versions you need to install, etc., etc. When you install an RPM, all the package of all the compilation is already done for you, so you don't have to worry about that. So it's just up and running for you. Also means it's easier to maintain. Like if you compile PHP for yourself and you deploy it on a server or whatnot, as soon as there's a security fix, well, never happens on PHP, but in the unlikely event that there's a security fix, you are the one responsible. You have to recompile the PHP binaries again, deploy it to your server or servers, etc. If you do an RPM, people will do that for you, and the only thing you have to do is do an RPM update, and you're up and running again. So it makes it much more easier. Another thing is that a lot of people nowadays use configuration management tools, like Chef, like Puppet, like Ansible, and they do that with the help of, for instance, Vagrant, or they just use it on AWS or Rackspace or any cloud system. And having packages that are just there, which you can install, makes your life much easier. Like with Puppet, you only have to say, okay, install this package, and you're done. It's pretty much a one-liner. So instead of doing all the manual compilation for every system and automate that, just one single one single line in your configuration management scripts, and you're off and running. So that makes it much, much more maintainable in the end, especially nowadays when our infrastructure is not just a simple shared hosting LAMP stack, but like really big systems, multiple memcache systems, multiple web servers, etc., etc. Now, so I will try to show you a bit about RPM usage before I start to talk about how to create RPM packages. And when you use RPM packages, you have pretty much two options. Use either RPM or use Yum. And Yum is like some kind of front-end-ish type of system that actually uses RPM packages. There will be a lot of code on the screen, a lot of output. So hopefully you can all see this. So what I do here is I have a system, in this case a CentOS system, and I want to search for a package called Xdebug. I want to install Xdebug on that system. So what I do is something like yum search, in this case for the keywords PHP and Xdebug. And then all kinds of things will happen in the background, and it will return information about, I've got 3 packages for you that actually is about PHP and Xdebug. Namely PHP Packle Xdebug, PHP 5.4w Packle Xdebug, and 5.5w Xdebug. Obviously, one is an old PHP version, one is PHP 5.4, and one is probably PHP 5.5. So I can actually look inside the repositories, just like Composer can use repositories, that I have enabled to see what kind of packages are there. I can search very quickly inside the system. Suppose I want to have more information about a package. I can use yum info for that. I can say yum info, in this case php-packle-xdebug, and it will show you information about the package. You can see the name of the package. You can see the ARC, and the ARC stands for architecture. Now, if you have binaries, this will be either x86-64 for 64-bit systems, or i3-86 or i6-86 for 32-bit systems. Nowadays, it's x64 bits mostly. You've got the version number of this package. You've got the release number of this package. And you've got some more information, like the description, like the license, which license is combined with this package, etc., etc. So yum info gives you detailed information about a package. It doesn't install it, it just gives you the information. So this is a package that is not installed yet, but I can also get information about the things that are already installed on my system. So you can do yum list installed, and I get a whole list of all the packages, and I snipped away a lot of things here. But you can see that the first package that's installed is GUIP with a certain version number, make dev, etc. And you see, once in a while, you see the yum plugin download only .no arc. So that means that this is a package that doesn't really contain a binary and can be used either on 32-bit platforms or 64-bit platforms. So when you have PHP code, for instance, your PHP code doesn't really care if you're running it on a 64 or 32-bit system mostly. So if you package your own PHP application, you probably package with an architecture of no arg, not 32 or 64-bit. What you see here as well is where that package came from. So for instance, the GeoIP package came from a repository called epal. The Yum plugin download only came from a repository called base. A lot of other stuff came from a repository called Anaconda, CentOS, etc., etc. Those are packages that are actually installed during installation of this CentOS system. So it creates sort of a temporary repository for that. So I can actually see what's installed, what versions of a package is installed, and I can actually see where that package came from. One cool thing as well is I can look inside a repository and see what's going on. So what's inside a package. So in this case, I use another application for that called Repo Query. -Q, -L, and then the package name. And it just displays these are all the files inside the package. So if you're going to install PHP Pagel Xdebug, it will install these files on these path names. So the Xdebug any file, the actual xdebug.so file, some information in the documentation, etc., etc. You can work away the other round too. So for instance, I can actually query a file on my system and it will show you information on which package it belongs to. I can do that with -Q, -F, so rpm -Q, -F, with a certain file, in this case .viminfo in my file. It will see, well, this file, viminfo file is not really belonging to a package, which makes sense because it's like a temporary file. However, I can check rpm -qf, and I will see on user bin PHP that it says, okay, this file belongs to PHP 55W, CLI, etc. So this is the PHP binary for the CLI PHP binary for 5.5 coming from that package. So if you have a file and you have no idea where it came from, you can actually use rpm -qf to actually figure that out, which is really cool. Another thing you can do is there's an option in Yum again called what provides, and it will actually tell me, okay, I need a file called user bin PHP, for instance. Which packages do you know of that can actually provide this file? And I'll give you a list. So it will say, okay, it will be provided by PHP CLI 5.3.3. It will be provided by PHP 55W CLI. And it will be provided by PHP CLI. But you can see the repository is either the base, webstatic, updates, and the last one is called repo installed. That means this is actually the file that is installed. So in this case, user bin PHP has been installed by the PHP 55W CLI package. To make it a little bit easier, you can disable all the repositories, and it will just say this package of this file is installed through this package. And you do that with disable repo is star in this case. Now, this is just for querying information about packages on your system. Now we want to install stuff on our system. And in this case, I'm going to install an application called Screen. Anyone used it? Oh, awesome. Cool. So a lot of people know about Screen. It's really awesome if you do command line work, especially with remote systems. Take a look at either Screen or Tmux. Awesome applications for that. So what I'm doing here is doing a Yum install Screen, but obviously you can't really install as a normal user, so you have to do that through super user rights. So in this case, sudo Yum Install Screen. You will see it will do all kinds of information. So there are like Yum plugins that it will check the download only in a faucet mirror. It's not really relevant right now. But you will see that it will say package screen x86 64 blah 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 will be installed, etc. And in the end, in the dashed lines, it will give you an overview on what actually is going to happen as soon as you press yes. In this case, it will say, I'm going to install the package screen from this architecture, for this version, from this repository, this will be the file size that I'm going to download or install. After I say yes, it will actually do that. It will run that command and those transactions. And then in the end, it will say, installed screen, complete. And now I can just use screen and do whatever I want with it. Now, suppose I want to get rid of a package. Just as easy, I can say sudo yum remove screen, and it will give a list again from this is what I will be removing, screen, this version, this architecture from this repository, and this file size. And in the end, if I say yes, it will say I just erased screen, removed it, and everything is complete. So you can find out exactly what's going on before it actually does it. So you always have the option to say, well, let's not do that, or let's change it, or whatever. But this is just a simple package with no dependencies. Let's try to install Tick. And Tick is like a front end for Git. So obviously, it will probably depend on the package Git, because it's pretty useless to have a front end for Git without having Git on your system. What you see here is that it actually say package Tick will be installed, and then you see processing dependency Git for package Tick. So it knows this package depends on the Git package. And the funny thing is that the package Git itself depends on other packages as well. In this case, the Perl Git, the rsync, Perl Git again, open SSH clients. So the whole dependency tree will actually be figured out by, in this case, Yum, and it will say, oh, these packages you did not install already, shall I install it for you as well? In this case, I have a list of saying, I'm going to install Tick, but I'm going to install the dependencies for Tick as well, namely Git, open SSH clients, etc., etc. Would you like me to do that? In this case, later on, I can say yes. You can see completely all the transactions that will be run, and in the end, it will say, I installed Tick, I installed all the dependencies for Tick, and everything is complete. This should be fairly obvious for most people, right? So querying RPM packages, querying repositories, and installing and removing applications or RPM packages. However, since, well, it's there for a long time, but not a lot of people actually know it, is Yum actually has a transaction history. You can actually say sudo yum history list all, and you get all the transactions that's ever done on that system. So you can track when a package is installed, why, how, etc. It's in there. So in this case, I've done 18 different Yum transactions. So the last transaction I did was I erased one package. The transactions before that, I installed 6 packages. Before that, I erased one package again, etc. You see all the way at the bottom that somebody, the system user, installed 217 packages. Probably this is installing the base system. So you can have a complete history on what happened during the installation of your system. You can also pinpoint one single package and say sudo yum history package list Tick, and it will show you which transactions was involved in the package Tick. So in this case, transaction ID 17 installed Tick, and transaction ID 18 erased Tick again. So if you want to figure out like, oh, but I installed Tick and why isn't it working on my system, try to see if it's actually there, and if it's not, you can figure out why it's not there, who removed it, when did they remove it, etc. Other way around works as well, so you can look inside the transaction ID and get all the history from that. So in this case, you see sudo yum history info transaction ID 17, and you see what's happened. So in this case, the command line I ran was install Tick from user me in this case. And what did it do? It installed the dependency Git, it installed the dependency open SSH client from the base repository, and in the end, it installed Tick from the EPAL repository. So you can find out all information about packages, where they came from, who installed what, etc., etc. Who knew about Yum history? Not a lot of people, a few. Okay, cool. At least you learned something, right? So that's a win. This is all through Yum. And Yum uses repositories, so you don't really have your own custom RPMs yet. But sometimes you have a website that says, oh, I have an RPM package here for you. You can download it and install it on your system. This is normally done through RPM. And what I always use, and I know this is a really bad way of remembering it, but the only way I remember it is RPM minus HIV. This is how I actually remember how to install packages. I know it's too bad, but... So RPM HIV, install a package. I said before, you can query a package, the contents of it, by using RPM QL. In this case, you only need the package name. So not the version and .rpm in the back, but just the name of the package. In this case, tick or screen or whatever. You can also do a QF that will query for a file, etc. RPM has got loads and loads of functions. I think maybe even 90% of the functionality of RPM I don't even use. It's really, really powerful, but even the few commands that you use, more than enough. Okay, so this is about creating, of installing files. Let's try to create packages. And the best way to explain how to create packages is to actually demonstrate this. Obviously, I won't do it live. But if you want to create a package, there are certain things you need. So first of all, you need sources, right? You need something that needs to be packaged. Optionally, you have things like patch files. So could be that you have a certain application, but you want to create a package that does something a little bit different or have another feature that it's not in the main package, but you want it as well. You can actually add those patch files as well. And then the RPM can actually take care of that. You probably need any other things you would like to add. Documentation, examples, init scripts, all custom things that you want, you can add to your RPM as well. Doesn't really matter. There is not really anything you can't add to RPM packages. And the most important part is you need to have a spec file. Spec file is really important because the spec file defines what we need to do with an RPM package. Building is pretty easy, as long as you get your spec file correct. So this sounds really easy, obviously, but getting a spec file correct is really hard. So you spend a lot of time configuring your spec files, try to run it again, see what's wrong, etc., etc. But as soon as the spec file is correct, you actually have a system that will build packages from sources in a way that it will be the same over and over again. You can automate your stuff really easy as soon as you hit something that's configurable by a spec file. If you're going to build, you're going to build it with a tool called RPM Build. And the most important thing is that you don't build as root. If you're going to look in building RPMs, pretty much every site says don't build as root. If you want to figure out why, please do try and build as root. You probably will have to reinstall your system sooner or later. RPM building is done through an unprivileged user, like your own user or maybe a separate build user or whatever. As long as it's not root, it will mess up your system sooner or later. So let's try and build an RPM. And for this, I have a really awesome tool I've written. It's called Auto Bug Fix. And Auto Bug Fix is the world's first automatic bug fixer. It will actually fix its bugs while you type them. It's that awesome. It will actually know before you typed it that you're going to type something wrong, and it will disallow you to type that code. All of a sudden, I can't type any PHP code anymore, so I don't know why. But Auto Bug Fix has got 3 files. It's got the binary Auto Bug Fix, it's got a license with it, and it's got a manual page. So you can do, on your command line, you can do man auto bug fix, and it will show you all the options that that application has. So it's really easy just to demonstrate how it works. So what I'm going to do, I'm going to get that package, AutoBugFix version 1.0.tar.gz. I can get that from the AutoBugFix website. I can add patches. Somehow there's a bug in my AutoBugFix application. Ironic, I know. So there's a hotfix I like to add as well. And I know there's an extra feature coming on, but it's not in version 1.0 yet. But I created a patch for that already, so that my RPM will actually have that feature. And I add other files, like the license files, the README files, etc., etc. And the last thing I need is the spec file, autobugfix.spec. Now, I told you before, the spec file is the most important file because the spec file is actually a mixture of a script and configuration file that tells RPM build how to actually build RPM files. They can be also used for building source RPM files. And source RPM files are all the information needed to build RPM files from that. For instance, if you install an open source system like CentOS, etc., all the packages there are actually created from source RPM packages. So you can actually use that one, change packages however you see fit, because what CentOS does is they take the source RPMs from actually Red Hat in this case. So you can really easy, well, not easy, but it is possible to actually build your own operating system from either CentOS packages or Red Hat packages or whatever, because all the packages that you need to build that operating system are there. It's open source, and you can use the source RPMs for that. But let's go back to the RPM building itself. So RPM build actually needs a directory structure, something that looks like this. So you have an RPM build directory, and there are 6 different uppercase, I don't know why, uppercase directories inside. Sources, spec, build, build root, RPMs, sRPMs. Obviously, sources is where all our source files will in. The autobugfix.10.tar.gz file will be in there. The spec file, however, will be inside the spec directory. The build and build root directory are actually directories where whole building of an application will take place. And the output of that building will be done in RPMs and sRPMs. So the only thing you need is after the build, take a look at the RPMs directory, and your RPMs will be there, if you're lucky. So what we do is in this case, we copy manually our source files into the sources directory. It's possible to use URLs inside the spec file. I will show you later, but it doesn't manually copy this from the URL, so you have to do it automatically, so you have to do it manually. You have to copy the spec files into the specs directory, and if you install a source RPM, this will automatically be done for you. So this is why sometimes creating something from a source RPM is easier, because you don't have to get all the information yourself. What we do then is we're going to say RPM minus V verbose minus BA. That will say build all with the path to the spec file. And then it will start building whatever the spec file says it has to build. That could be 1 package, but it could also be 10 packages. If you're going to build HTTP, the server, the Apache web server, it will output something like 4 or 5 different packages just from 1 spec file, like the debug version and the pre-forked version and the normal version, etc. And I said before, the RPM and the source RPMs are actually created in the directories as specified. So, the spec file, most important file, how does it look like? This is a really simple one. They can be really complex. I will show you a little bit later on. But it looks something like this. So the first part you see here is actually the configuration part. So it will show you what is the name of the package, AutoBugFix. What is the version? This is version 1.0. What is the release? Normally you have something like this, which means it outputs something like 1.EL6 or EL5. Things like that. You will notice them inside RPM files if you install them. A summary, very important, because you can actually, when you run Yum search, for instance, it will actually use the summary to figure out, okay, what are you looking for? So normally it's only the name and the summary that is searched upon. But you can have more information inside the description, and you can actually use Yum search to search inside your description as well if you want to. But try to make your summary as specific as possible. You can have a group, in this case development tools, so it can actually see that, oh, this is something that belongs to a certain group, so it's easier to track, easier to figure out. I want to install developer tools, just show me what kind of developer tools there is, etc. There's a license in there. You can see the URL where you can find information about the package, and here you see things like source 0, patch 1, etc. So all the source 0, source 1, source 2, source 3, etc. are source files. Those files are needed to actually start compiling your application. The patch files are just patch files that you can add, like new features, like hotfixes, etc., etc. So in this case, I only have one patch file, namely the hotfix001.patch. Now, these two files, the source files and the patch files, are from the same server, but it might as well be that somebody's created auto bug fix and somebody else created a new feature, and this package, which is created by, again, somebody else, just aggregates them and puts them together. So as a source developer for the auto bug fix, you don't need to be the spec file maintainer, or you don't need to maintain all the patch files. Somebody else can do that for you. It doesn't matter. It only needs a URL. Where can I find the tar files? Where can I find the patch files, etc. Things like build root isn't really that important. Build arc, in this case, the auto bug fix file is a PHP file. Go figure. And so it doesn't need an architecture. It can run on 32-bit systems, can run on 64-bit systems, doesn't matter. I'm the package maintainer in this case, but this requires PHP common. Why? Because it's a PHP file. So you can't run you can't run auto bug fix without having PHP there. So I need PHP common in this case. So these are the dependencies that will be installed as soon as you try to install auto bug fix. It will say, okay, you want to install auto bug fix, let's install PHP common as well. Again, there's a description with some information, etc. So this is like the config part of your spec file. Underneath, you have the actual script file. And this is really fun because this is all macros. So everything you see here will actually be resolved into all kinds of other stuff. But this is actually what makes it easier. So the first thing you see is $prep. And this is the part of the RPM building where it will prepare for whatever it needs to do. In this case, it will say setup -q. And setup -q, again, is a macro that will actually unzip a tarball and just put it in the correct directories. So normally you have to do that by yourself, but because every package basically is from a tarball, they made something called setup to make your life much easier. The other one, $patch1, just says, okay, the patch file, the patch1 file I showed you, is actually a file that needs to be patched onto whatever you extracted from that tarball. If you don't have patch files, could be in your PHP application, you can just leave that. You don't need to do that, but a lot of applications inside RPMs actually use patch files. The next step is the build step. In this case, it will build stuff, it will compile stuff. Now, obviously, it's a PHP application, it doesn't need compiling. It doesn't need configure, make, install, and stuff like that. So this step is actually empty, I don't need it. However, the next step is the install step. And this is really confusing because this is not installing it on your main system. This is installing it inside the RPM build directory, like the build and the build root directories that are there. So what the RPM is actually doing, the RPM builder is actually doing, is it will compile the information like my tarball, it will do stuff. In this case, it won't compile, but there's a source tree there. And it will copy everything over from the build root source directory over to the build root directory. So I just copy files over, and from that place, in this case, it will be, I'm going to make a directory /user local noxlogic bin. I will copy a file, auto bug fix in that directory. I will create a man directory. I will copy a file into the man directory, etc. And the clean phase is about cleaning everything up later on. So until now, the only thing I did was inside an RPM build directory. The most important part is the files part, because here we actually tell RPM build which files do you need to package. In this case, I need to package doc files. You see %doc, and it knows that all the files inside the documentation should be inside user share doc, whatever. I need to have a directory user local. I need to have a directory user local noxlogic. I need to have a directory user local noxlogic bin. A lot of directories, but I have to specify all of them. And then I will say, you have to have a file called user local noxlogic bin autobugfix, and you have to have a manual page called autobugfix.1.gc. Now, what RPM build will do in this case is it will see if it can matches these files in the RPM build directory you created. If it can, it will build a package. If it can't, it will blame you, and you have to change your install scripts or change your configures or build scripts, etc. In the end, you have something called RPM lint to actually check your configuration. So in this case, I run RPM lint autobugfix.spec, and it will say, yeah, okay, there are 0 errors, but there's one warning because you hard-coded the package tag. Well, in this case, it doesn't really matter. So this is like you can compile you can check your spec file for errors, and if everything is okay, you can actually try it through RPM build -BA or -V if you want as well with the spec file, and in the end it will either succeed it or not. And if it doesn't, you have to change the spec file. If it did, inside the RPM directory, there will be an autobugfix RPM. Let's assume that everything went okay, and I have the spec file. I can use my RPM -QIP to get some information about that package. And you see the name, autobugfix, the version, the release number. You see it's not installed because it says install date is not installed. Which host did you build it on? When did you build it on? Who built it? What's the information, etc. So now you actually have an RPM file which you can use. Install it, again, RPM, HIV, autobugfix, etc. And now it's actually installed in your system. This is pretty much what you need to do. The spec file is the most important thing. All the rest, getting a source file, etc., is not really that difficult. But making the spec file, there's a lot of templates you can actually use, but it's a lot of trial and error which you have to overcome before trying to create them. This is an example from Nginx about how Nginx does everything. So there's like some defines on top, but you see here the name is Nginx, the version number, the release number, etc. But you see it has got 7 or 8 different sources. So you got the tarball at first, but there's also other kinds of sources like the sysconfig, the init, the configuration, the examples, etc. There are license information there, different kind of groups where it needs to be installed. You see build requires, because if you're going to compile Nginx, you need to have the zlib development files, you need to have the PCRE development files, you need to have Perl, etc. So before you can actually build it, it will show you, oh, these are the dependencies you need to build it as well. And there are requires there as well, because you need, for instance, init script before you can actually start and install the RPM by itself. So these are much, much more complex, obviously, but they all follow the same principle, like do some configuration in the back, or in the top, and have the configuration at the bottom. So you can see here as well that in this case, it says this is the bottom files debug. That actually means that it's a separate package which only got one file, namely nginx.debug, which is the debug version of nginx in this case. Sometimes packages will do things to your system, like installing new users, installing new groups and everything. You can actually use the %pre and %post for that. So in this case, you will see that as soon as you install an nginx application, it will actually run the things like add check nginx to check config and actually print a banner information so you can figure out what just happened, etc. You also have a pre and post when you uninstall to get rid of the users, etc. So this is for installing packages. Now, obviously, if you have a lot of packages, it also makes sense to have it automated inside your own custom repository. Fortunately, having repositories is really, really simple. The only thing you have to do is you have to install a file called create repo. You have to create a structure on a public web directory. You have to copy files over. And you have to run create repo for every directory that you created. That's it. And it's not really harder than that. If you look at repositories, you normally notice that they are called us RPMs and RPMs x86, 64. So those are the architectures again. So I can create this on my web server, and I can run create repo on these two directories, and it will actually create something called a repo data structure, which is like a simple database with all the information about all the packages that are found inside these two directories. So what you normally do is you copy your RPM files over to these directories, run create repo, and then your, all the servers that actually use that repository can find the updates or find the new packages on your system. So it's really easy to actually do that. But if you create a new repository, you also need to add your repository to Yum. And that's really easy because there's a file called etc yum.repos.d directory, and there you can add your own repository files. In this case, it's a repository for my own custom stuff. And it's found at repo.noslogic.nl, etc. This pretty much is the same thing that you will see when you install EPEL, when you install the base CentOS installations, if you install WebTatic, etc., etc. They all follow the same system. In this case, I can run sudo yum repo list, which actually shows you what kind of repositories there are on your system. And you can see here that now the Noxlogic packages are there as well, and it has 2 packages. So there are now 2 packages inside the system. Not much compared to the EPEL repository, which has 10,000, over 10,000 packages. I'm not there yet, but I'm trying to create more applications and RPM them. But you can also see what's available on that system. So in this case, there's an auto bug fix application, 1.0 version 2 in this case. And for demonstration, I actually created a PHP MyAdmin package there as well. I'm sorry, I'm a big PHP MyAdmin fan. Don't hate me for that. And you can do all the same things you can do with other packages because it's completely the same thing for Yum and RPM. So I can do Yum info auto bug fix, and I get all the information. I can also install it in this case. Install the application, yes, I can do that. And then in the end, I have my auto bug fix on my system. Now, obviously, you will not do this with your own applications every time you want to deploy something. However, if you need something different inside PHP, because there's some really strange extension that you want to use but isn't really compiled with it, and you need to recompile something like that, don't recompile it from scratch on your system. Create an RPM for that. Why? Because it's much, much easier to maintain. And because we actually are doing something with RPMs, if you do it right, you can automate the whole process. in fact, and this is what actually is happening on some of my customers, they have PHP tools that as soon as you deploy and tag something in the GitHub master, there will be a webhook called, and that webhook will actually compile the RPMs, put them on a web server, so you can automatically update all those servers that are available with that new package, just by tagging and committing something to the master repository. And it works because everything is automated. Everything can be done once, that could be twice, 10 times, and everything has the same result. If you're going to try this at home, and you really should, just for the sake of trying, there are some tips. When developing, try to clear your cache once in a while, yum clean all. If you don't, what happens is Yum will not see that you have new applications, new RPM files inside your repositories. It will only check every 90 minutes or so. So if you are trying to figure out why is my package not showing up, it's because it's cached. So try to do a yum clean all before you actually try and figure out the packages. Normally it's not really a problem. But it can also mean that after 90 minutes, you need to refresh all your data. So if you have something like, there needs to be a hotfix, and it's RPM'd, it has to be installed, it might not be possible that it's available until the 90 minutes have gone, because then the cache expires and it will check again on your system. Another thing that will often go wrong is that they copy the files over to the web server, but forget to run the create repo command. Obviously, when you automate stuff, it's not a problem. If you do, you're going to have a problem, because if you forget it, it will not show up, because it's on the system, but it's not in the database that create repo creates. So you have to be really careful about that when you create that. If you're going to do this, you probably want, maybe even need, something called a repo package. Anyone installed the EPEL repository? Okay, so what they actually say is, this is an RPM file, just run that RPM file, and that will actually install everything that you need to gain access to the repository, like the signature keys, the yum.repos.d file I showed you before, etc. So this is what normally a repo package does. It's a fairly simple package as well. You can actually base the repo, base that package on, for instance, the EPL repo package for that, so you can use that one. What I didn't discuss, because it's a really difficult topic which needs much more explanation, is that you should sign your package as well. Anyone familiar with PHP key signing? A few. Okay, that needs to be much more. What you actually do in this case, you sign a package, you put it on your web server, and if somebody downloads that, they are guaranteed that it will be the same package that you uploaded to there. It cannot be changed, because if it changes, you will detect it. Sometimes you see that when you download RPM files, it will say, oh, you know, I can't trust this key. Should I install it anyway? And you probably say yes. But normally that means that, okay, so maybe you should verify where that package came from, etc. You could sign a package really easily, but that's something you can find in the documentation later on anyway. Okay, so basically, these are the steps that you need to do to create RPMs. So you can actually create them, and you can actually deploy them onto a repository package. Okay, any questions? There's a few.
Hi, very good talk.
Thanks.
I have a few questions too, if it's okay, but they're short.
Yeah.
The first one is about dependencies versions.
Yeah.
You've been talking about PHP, but how do you tell the system, like PHP 5 or?
You can say this. I have it in the Nginx slide as well. You can actually tell the dependencies. that it has to be greater or equal to, in this case, in its scripts, 8.38. So you can add that pretty much the same way as Composer does it.
Thanks.
So you can do that as well.
The second one is, if I understood, you list the files to include into the RPM. Can you automate that?
Sorry?
Can you automate the list of files that you put in your spec file?
Can you automate the file?
38, I think.
You mean the source one and the patch one files?
2 slides further, that one.
These ones?
Yeah.
No. Well, not really. Let me put it that way. And this is because this is why you actually define what goes into the package. If you say, oh, everything you got, just put it in the package, that would sort of kind of miss the point of package management, because what you need is to have a package that is completely whatever you specify it. And if you say, well, I don't care what's inside the package, you might as well just go and fetch a tarball and install it like that. So, no, normally you just put something like that. You can automate a little bit, but try to do it manually. And most of the packages aren't really that big. For instance, if you look at HTTPD, for instance, it's a huge spec file, but it's still comprehensible, even the files section for that. Okay? Any more questions? This one there. Oh, a guy with a beard. So that's going to be like a really cool tech question. I've been using Unix like 1960 and...
I'm not that old.
Oh, okay. I'm sorry.
It's actually a simple question. Do you have to take any special care that after you've uninstalled a library, that no files remain on the system?
Sorry, can you...
Do you have to take... Sorry.
Yeah?
Do you have to take any care that no files remain on the system after you uninstall a package?
Yeah, obviously. What an uninstall of a package does is it will only uninstall the files that are inside the files directory, but only if they matches the same signature. So if you're going to change a file, like a configuration file is in there, and you change it, when you erase the package, it will actually say, okay, I'm not really going to erase it because you have manually changed it. So it's still there. If an application creates files, then they will stay there because it's not inside the files list, so it won't touch it by default. Normally, the packages are okay enough. Like, for instance, if you uninstall MySQL, for instance, your varlib MySQL tables will still be there because they're not inside the package.
So is there a way of telling the script to remove files that were generated?
No, because the RPM does not know that, only application know that. So,
okay, thanks.
Yeah? Too many questions.
Cheers. The Yum commands were really, really useful. That's opened my eyes, but this might be a really amateur question. Is there a Yum command to see what the package will install? I'm forever looking through comp files, trying to find where man files, looking for where the configurations are, looking for where things are, and sometimes it takes forever.
I'm not 100%...
Sorry, is there a reasonably easy way to see through Yum or through RPM what files will be installed, so I can find when it has installed where the configurations are? Data
I showed you before that in the beginning there's a command. Let me see if I can get it back for you. This one, repo query, for instance, that will actually show these are the files inside the repository.
Yeah. Oh, right, that's the full routes of where they'd be installed as well.
Exactly.
Okay, thank you.
Right. All right.
How are updates handled?
If you have an update and you run yum update in this case, it will detect that you already installed a package and it will show you like, okay, I have an update for this package. Will you want to install it, yes or no? So it can detect that based on the name of the package, the version and the release as well. So if you have hotfixes and everything, you need to run yum update, and it will automatically update the packages if you like to. So, like that.
Okay. And what happens if there's a file name conflict? So if you've packaged a file that already exists on the system that you're installing to?
Oh, that's actually a good one. I don't know, to be honest. It's really easy to figure out, because make a package that actually installs user bin PHP, for instance, and see if hell breaks loose. To be honest, I don't know. I'm not 100% sure if Yum will allow you to install that package, if it already detects that it overwrites a file that is being guarded by another package. Would be interesting to figure out. I can't say that, but trust me, I will know by the end of the day.
Great, thank you.
Right.
Yeah, you mentioned that in the sources list, if you use a URL, you have to manually install. Can you just explain that?
Well, the thing is, the RPM build is really a dumb application, because it only does what says in the script. But before it can do stuff, it needs to know which files do I need to work with. And those files are listed in the sources and in the patch configuration. However, if you actually use a URL inside the spec file, in this case, let me check it, the source 0, it will not see that, okay, this is a URL, let's try and fetch that from that URL and put it in the system before I build it. It doesn't do that. So what you need to do is manually copy the URL, put it inside the sources directory, and then it will happily do its stuff. So that's a bit of annoying. I don't know why this is the case, but so you normally define a URL, but you still have to manually copy it over and install it. Okay? Any more? Too many? Oh, somebody with a mic coming over.
Hi. When you spec the sources, you spec the patch, but on the files, the patch is not listed.
Here, in this case?
Yes.
Okay.
But further on the file list, it's not listed.
Here, no, because what happens is you have the source file. That's going to be, in this case, just extracted. Normally you compile stuff. And the patch files are actually implemented before you compile that. So inside the setup phase of your application, during the build, the setup will actually do things like patch the file. This is what percentage patch 1 does.
So that patch 1 is actually applying the patch that you supplied on the original files?
Yeah. And then once you have built it, and in the case of PHP files, you don't really have to build something, then you have, in this case, an auto bug fix file that's already patched. So at that point, you don't really care about the patch files anymore. Okay?
Okay.
Any more? Yeah, sure. I'm here all day.
Where can I find template spec files to copy and alter? Would they be in the SRPMs of the CentOS distribution?
Yeah, for instance, you can take any spec file you want, to be honest. Mm-hmm. This is just Nginx, but take simple ones if you want to.
Can you recommend a simple one?
Yeah, my auto bug fix.
That's not in the CentOS 6.5 distribution though, presumably?
No. Simple ones. To be honest, I have no idea. What you could do is just go to the SRPM directory of either CentOS or Red Hat or anything, and just try and get a very small file, because normally the spec file will be small as well, and that would be a really good way. However, there are a lot of tutorials out there that show you how to set up a spec file, so it's not really that hard to start with.
Thank you.
Okay. Last one. Okay, cool. So that's basically it. All right, thanks.